Actually, I'm present. Due to some network issues, there is
Okay, you are
some voice
facing some kind
lacking.
of error.
Uh, yes, sir.
Okay.
So I'm trying to.
Okay, we can move to the next candidate. Okay, so next participant. So next is forecasting patient length of stay for optimal hospital resource allocation. Who is the presenter?
Yes, sir. Again.
Okay, could you please share your slide?
Yes, sir. Yes. My slide is visible, sir. Sir, my slide is visible.
Yes, yes, your screen is visible. Yes.
Okay. Okay. Our project topic is forecasting patient length of stay for optimal hospital resource allocation. Myself, again. This is the contents we are going to talk about: introduction, literature survey, methodology, research discussion, and so on. Let I introduce the introduction. Nowadays, efficient hospital research management is one of the biggest challenges in every hospital. During COVID time, we are facing this issue, which is some hospitals have more resources, some hospitals have less. So that time we cannot properly make data-driven decisions, which means it in this particular hospital needed for certain amount and another hospital needed for certain amount. So this is one of the problem. Plus, in resource means we have defined various things, which is bed and doctor availability and drugs availability and nurse availability. In this paper, we are mainly focused on bed only, hospital bed. So, in identifying the patient, one of the key factors for identifying the resources is on patient length of stay, which means once we identify how long the patient is staying in hospital, we can easy to understand and allocate their resources. So, and this is our general introduction. Next, we explain the literature survey. In first paper is prediction length of stay for across hospital. In hospital, we have various departments like ophthalmology, cardiology, dermatology, and so on. In this each department, they are collecting the data set because every department have certain disease medical parameters. So that parameter used to their predict the length of stay and they give the results in average as well maximum length of stay. They are not properly cannot accurately defined, which means the patient going to stay in 10 days or 12 days. They are giving average value as well maximum value. Next paper prediction length of stay in intensive care unit ICU. Generally in hospital ICU, they are generally presenting two types of patient, which is pre-operative, next post-operative. After performing operation surgery, the patients also stay in ICU. Next, some critical situation patients also stay in ICU. So these two types of patient data medical parameter used to they are predict how long they will stay in ICU. This is the main point in this paper. Next paper is prediction length of stay. Next paper is prediction length of stay in emergency department in COVID-19. In COVID situation, lots of patients came in hospital. So that time we are facing lots of issues. So in this paper, what they are focusing is based on their medical every patient medical parameter used to identifying the threshold. Based on their medical parameter, usually if the patient is possible to stay in greater than 4 hours, so that patient we need to assign in hospital. Otherwise, we can suggest their general medicine and discharging. So this is the main point in their threshold based on 4 hours threshold. Next paper is two-stage model. in machine learning aspects, length of stay is the continuous variable. That patient may be staying 2 days, 3 days, 4 days. So this is the continuous variable. So this is what we call regression. So they are here in this paper. They are used for two-stage method, which is CORP analysis, which is classification and regression tree analysis. Both the algorithm used to they are using to predict the patient state. These are the literature. Then our main objective is developing the robust predictive modeling, which is directly applied to hospital database. In generally, hospital maintain the main database, which they are collect all the patient data, and we are separately maintain another database, which is hospital insights DB, which means we are collecting relevant features and relevant data set into collect and store into hospital insights DB. Then we perform operation, machine learning operation and visualization operation. And then once we accurately predict the patient length of stay, it will helpful for easily to resource allocation. And then when new patient is came in hospital, they are performing medical procedure and a diagnostic procedure. The data is continuously updated in hospital entity. The data also we are getting and predict the continuous length of stay, which means continuously update the model when new data is come. Then all the data begin the scene, all the data processing process has visualizing Power BI dashboard, which will easy to understanding the visualization, how many patients are staying particular day or month, and what which patient gender wise male female patients are staying in hospital. So the visualization we are showing. Next, this is the methodology architecture diagram, which is hospital main database, next hospital insight database. Why we are splitting hospital main database and hospital insight database? Because hospital main database is storing all the data, which means once the patient come in admitted in hospital, there all the data we are updating in hospital main database. That time we are also directly extracting and apply operation in hospital main database. It will increases the load in database load. So we are splitting in another database, which is hospital insight database. That database where only collect relevant features and store it to hospital insight database. Then this database, hospital insight database, we are performing data retrieval, then performing data pre-processing, ED analysis, which will understanding the how data is distributed, what are the patterns begin the scene happens. Then we are performing machine learning process. Then after performing machine learning process, we are choosing the one best model, which is here prediction model. Then when new patient is came in hospital main database, which is we are storing their patient data in hospital main database, that relevant feature extract in hospital insight database, that features were feed into prediction model. That prediction model gives in accurate patient length of stay based on their medical parameter. That length of stay we are stored in resource data. Then that these are the resource data we are reflected in Power BI dashboard, which will easy to understand the hospital management team. This is architecture. Then our main methodology is developing the predictive model, which will directly apply in hospital database. Then in our total data set, we are used for 2 million data, which is 20 lakh. So 20 lakh is when we perform in machine learning model, it is huge. So we are performing strategy-based sampling to extract relevant information only, then applying regression algorithm, which is XGBoost, random forest, precision tree, and adaptive algorithm. Then after applying algorithm, we are performing cross-validation as well. After performing 4 algorithm, XGBoost and the random forest, we are scoring less mean square error and continuously updating when new data is given and provide and showing the Power BI dashboard as well. Next, main novelty is our literature survey is focusing on in hospital we have various departments and department wise they are focused as well ICU patient wise focused and the COVID situation. Here our main novelty is we are used for CCS codes, which means CCS stands for clinical classification software. Like example, once we generally when patients have diabetes, we are generally saying diabetes. In diabetes, we have various types. which is type 1, type 2, and type 3. In type 1, maybe the doctor suggests for insulin or tablet. So every one disease we have various diverse factors. It's in-depthly go on. So this is the when this is the complex for when collecting all the data for specific disease. So here we are used for CCS codes. Every code representing unique disease. So this is the generalized predictive model. We are not focusing on any specific disease in hospital. We are focusing on generalized, whatever disease they have and whatever department they are claiming. So here our total CCS codes unique code is 256 unique codes we are used. Then we are showing real-time forecasting. We are Power BI connected with database. When new database came inserted in database, that is real-timely reflected in visualization, then integrating the data visualization. This is our main novelty. Next, this is the resultant discussion. We are used for 4 regression algorithm and performing 3 variations for cross validation and the real-time insights in the decision making. In first threefold cross validation, we are scored for first fold is 8.8. We are using metrics for mean square error. 8.85 we are scored mean square error. After performing threefold, we are getting an average mean square. This is our first threefold cross validation. Next for fivefold, then we are performing tenfold. Within threefold validation, XGBoost and a random forest for scoring less mean square error, which is the first threefold for 8.74, fivefold for 8.69, tenfold for 8.66. So we are prediction model, we are choosing for XGBoost model. Whatever data comes in, we are feeding an XGBoost model that gives length of predicts patient length of stay in integer wise, 3 days, 4 days, and so on. This is the dashboard, which will show you in hospital management team. This is we are performing used for historical data in hospital. Female patient, how many patients have stayed, and which age group patient has stayed, and the type of admission counts and the admission by year. Next is medical informed information. That patient is performed by medical only or surgical also, and the diagnosis code, which means every code represents unique disease like cardiology, ophthalmology, dermatology, and so on. This in particular diagnosis, what are the procedure has been taken by doctor? These are the procedure and the severity of illness. And that patient we are identify how they are severe in particular disease. Next, this is our main point, which is resources, which is particular for bed. In January, in first day, how many bed is occupied, and so where every day they are showing the how many beds are occupied in the count wise. So this is the historical data they are showing visualization. When new data comes in, that also lively updated and reflected in visualization. And year-wise also we are showed how many total counts are occupied in beds. So finally, what we are here conclude here is predicting. We are developing the predictive modeling framework, which will based on patient medical parameter, used to predicting how long the patient stay in hospital. And as well, we are showing the real-time visualization dashboard as well. And the XGBoost and the random forest model is we are scored in less mean square error and predicting more accurately. Our future scope is we are used for here in the CC score for only 256. In future, we are added and more cores. And AdaBoost regression model is we are scored high mean square error. This model also we are going to as well. We are using and one more algorithm in machine learning algorithm. That's it.
Okay, so Karthikeyan, thank you for your nice presentation. First of all, I have some few questions. So before that, let's check whether the audience having some question or not. So from the audience, do you have any question? So how did you get the data? So that is one of my first question.
Okay. First, we are mainly focused on Indian data because we are asking in various hospitals.
No, so you should, in your reference, have you shown it?
In data sets, sir.
Yes, data sets. You have shown in the data in your reference. You should show ideally because that is very important.
Okay.
Okay, so this is the data set you are using so that other people can do the same thing and they can reproduce the result. So that is very important in the research. Okay, and then after getting the data, you learn basically run various algorithm to basically predict that how long this patient can stay. Okay, so from the machine learning model, so whether you able to predict some kind of mathematical modeling out of that?
No, sir. We are not focused on this learning.
No. I'm saying that let's say that basically that machine learning is a kind of a black box. Sometimes we say black box model.
Yes.
Say you give some input, you get some
Yes,
output. You train off that. You basically try to predict what is the transfer function of the system. Okay. So from the machine learning model, let's say you are using random forest or let's say descent tree. Okay. So yeah. From that, whether you able to understand that which parameter is affecting more in terms of the patient staying in the hospital. So do you have concluded something that which having more weightage?
Yes, sir. I will show, sir. Because we are performing correlation analysis in our class variables length of stay, which is we generally mathematical call y, which is x has general information, which is gender and age and medical parameter. So I will show that. These are the my screen is visible, sir.
Okay.
These are the parameter we are used for, which is age group, gender, race, ethnicity, admission type, diagnosis code.
So these are the parameters based on that you are predicting. Okay, so this is what is so which factor affect more? So as per your understanding,
which factor affects more is
patient stay. So some of the factor affects more. So that patient stay will be longer. So based on this factor, you are concluding.
Yes. Where how we identify how particular factor is more impacting length of stay. We are performing correlation analysis. It is one of the mathematical analysis technique. It will perform, you may see, severity of illness score is highly impacting based on length of stay. This is the matrix which will apply in image series. And one more ANOVA analysis, which is analysis of variance based on length of stay. Severity of illness score is highly impacting based on length of stay, which is our class variant. These are the mathematical models that are used to identify how correlated to other class variants. Okay, sir.
Okay. Thank you for your nice presentation. We'll move to the next participant.
Thank you, sir.
Sir, is it audible?
Yes.
Sir, next paper is 542. Indumati Harika. Hindukuri Harika.
Okay. 542. What about 592?
Sir, can I give
later? Okay. So
sir,
542.
Hello, sir. Sir,
Yes.
Bisaya who am speaking. Can I give my presentation of 580 number?
Okay,
Number
so again
580.
start
Can I
with
give my
544
presentation?
and then you can give it later. Okay.
Okay, sir.
Okay. Wait. So don't worry. You listen to other participant also. Okay.
Hello, sir.
Yes.
Yes, sir.
Just a minute. Share 542. Design of reconfigurable sense amplifier for compute access.
Yes, sir.
Okay. Please start your presentation.
Okay, sir. Hello sir, my name is Indukuri Harika. Our title is Design of Reconfigurable Sense Amplifier for Compute Access. The other authors are Mr. R. Manoj Kumar, Mr. Dilli, Miss Geeta and Tejaswini and Jyotsna. Coming to the introduction of our paper, sense amplifier. Sense amplifiers are used to detect and amplify. Sense amplifiers are used to detect and amplify low power signals in the memories. So these are most important circuit in the organization of CMOS memories. While designing a memory, these are essential circuit because these are used to send small differential input values and amplifies to a digital one. This helps us to reduce the required power in the read operation of SRAM circuit. It is mainly used when data is read from the memory cell. In literature survey, first we have analyzed the paper of analysis and design of reconfigurable sense amplifier for compute access with high speed compute and normal read access. In this paper, mainly we have three sense amplifiers: symmetric single-ended sense amplifier, asymmetric differential sense amplifier, reconfigurable sense amplifier. From these three papers, we have observed that in reconfigurable sense amplifier, the power requirement, it reduces the power requirement and it also have the low bitline discharge delay. Coming to the limitation of this paper, it have high sensing delay for compute access. In a second paper, in memory computing with double word lines and three read ports for 4 operands, this paper tells about the symmetric single-ended sense amplifier. In this, we have observed that the limitation of this paper is it has high bitline discharge delay when compared to the sensing delay. In another paper, enabling in memory Boolean computation in CMOS static random access memories, it has a low sensing delay for asymmetric differential sense amplifier for compute access. And the disadvantage of this paper is it has high bitline discharge delay. The objective is to design and analyze the proposed sense amplifier for computing SRAM to reduce the power delay product for compute access. By taking the limitation of above papers, we have designed the new sense amplifier to reduce the power delay product for compute access. We analyzed this proposed sense amplifier with the other sense amplifier and compared different parameters such as delay, power delay product. So to reduce the power in the proposed sense amplifier, we have used the power gating technique. Mainly the power gating technique is used to shut down the power to the remaining circuits that are not in use. It is mainly used in the memory cell circuits to reduce the power for the future requirements. In resultant discussions, first we will see the parameters for total delay. Total delay is a combination of bitline discharge delay and sensing delay. Bitline discharge delay is defined as the time interval between the moment when the read operation is completed and the bitline voltage drops below a certain threshold voltage. Typically, half of the supply voltage during the discharge phase. Similarly, sensing delay is the time taken to detect for a circuit to detect a change in the input signal and produce a corresponding output. By combining sensing delay and bitline discharge delay, we have got the total delay for different sense amplifiers for different supply voltages. In this, we can observe that total delay of reconfigurable sense amplifier is less than the remaining circuits. The delay of proposed sense amplifier is slightly greater than a reconfigurable sense amplifier due to power gating technique. When we implemented the power gating technique, the total delay will be increased and the power will be decreased. It can be observed in power calculations. Here we can see that the proposed reconfigurable sense amplifier has less power than compared to the remaining 3 sense amplifiers. So in proposed reconfigurable sense amplifier, we can observe that it has less power compared to the symmetric, asymmetric and reconfigurable sense amplifiers. Here power is measured in the nanowatts. To know to know which sense amplifier is better for the further use in between reconfigurable and proposed sense amplifier. As proposed sense amplifier has more delay and reconfigurable sense amplifier has more power, we have done power delay product to know which circuit has the best use. In this, we can conclude that proposed reconfigurable sense amplifier has low power delay product when compared to the remaining sense amplifiers. So power delay product of proposed sense amplifier for ideal 1 volt is 951.0.5 nanowatt square. So it is a power delay product is mainly used. It is a matrix used to evaluate the energy efficient of a digital circuit or system. So it is mainly calculated by average power consumption by the power and delay of the circuit or system. So the future scope is, we know that the memories plays a crucial role in the semiconductor industry. So while scaling in technology, the multi-gate devices are used to design the sense amplifiers. So which enables to operate in a SRAM array with low leakage power. These are the references we have taken, and these are the main references we have concluded from the above paper.
So, Harika, it was a very good, nice presentation. But some of the thing would like to mention that you have not shown your tape out or the layout of your design.
Okay, sir.
So that is very important and crucial. I think how we are basically modifying the CMOS circuit or in the design such that you are getting some kind of improvement.
Yes, sir.
Okay, so that you have not shown. And what do you mean by sensor? Whether it is a voltage amplifier or current amplifier or power amplifier?
It is mainly a voltage amplifier, sir.
It's mainly a voltage amplifier. Okay, so what
There
is
are
the
different
typical?
type of sense amplifiers, sir. Voltage amplifier, current amplifier.
Okay,
In this, it mainly detects the small signal differences in the memory and amplifies to a 0 or 1, sir.
okay. And you have not shown the distortion after the amplification. So is there a kind of distortion in the after amplification of your signal?
Yes, sir. Sir, here
So
we can observe that these are
that
bit line
result
and
also you have not shown.
okay, sir. These are bit line and bit line bars, sir, in SRAM cell.
Okay, and what is the typical operating bandwidth of this kind of amplifier? Whether it is a single frequency amplifier or basically broadband kind of thing you want to design for?
Single frequency amplifiers.
It is a single frequency. What is the typical frequency of this one?
Sir?
What is the typical frequency of operation? Your design frequency, for which frequency you are designing this amplifier?
Frequency, sir. I think 1 gigahertz, I think. So.
No, you think it's not like you have designed it, you should know. Okay, anyway, so you don't have any other additional result other than this.
Yes, sir.
Okay, thank you. So we'll move to the next participant.
Yes, sir.
547. Srinivas Rao.
Sir, can you hear me, sir?
Yes.
Okay, sir. I'm sharing my PPT, sir.
Okay.
Sir, can you see the PPT, sir?
Yes, it's visible.
Okay, sir.
Please start.
Sir, shall I start, sir?
Yes.
Sir, good afternoon to everyone. I am Dr. Srinivasrao Gampa, working as professor in Seshadura Godlavaleru Engineering College. And the title of our paper is K-means algorithm and fuzzy genetic algorithm based methodology for distribution system planning with the distributed generations and shunt capacitors. So the contents are introduction, literature survey, objective, K-means algorithm, fuzzy GA algorithm, results and discussions, conclusions and future scope, and references. And the introduction is power sector, the analysis of load profile plays major role in estimating the energy demands, power generation, and power supply requirements. The load profiles is very important for efficient use and management of renewable energy sources for meeting the energy demands. So this K-means algorithm we have used in this to for clustering the load profiles. After clustering the load profiles for each cluster separately, we can design the requirements of the renewable energy sources. That is what we have done in this work. So these are the main references for our literature survey. And what we observed from the literature survey is, so far the algorithm mainly used for grouping the load patterns for smart meter data, for charging the people, and K-means clustering to develop energy consumption profiles and identifying consumer groups, especially for smart meter applications. And sometimes they use it for the demand management strategies also. So in our objective, what we did is we have used that K-means clustering algorithm in combination with fuzzy genetic algorithm for estimation of required distributed generations and capacitors for each cluster separately. So far, K-means clustering mainly used for clustering daily load profiles for smart meter applications, and we use the fuzzy GA methodology approach for clustering the load profiles. So actually, clustering is like starting a collection of items into groups based on their similarities. So from the raw data, we will group the different data with similarities, choosing some performance metrics. It's a kind of unsupervised learning. So here is we used a K-means clustering algorithm. Here is a brief introduction to the K-means algorithm. So K means the number of clusters. If a group in a group that can be divided into either 3 clusters, 4 clusters, or 5 clusters. Here K is the number of clusters. Here we divide the data. So first, randomly selecting initial cluster centroids. Out of the group, we select some K clusters, the same. We randomly select them and we calculate the distances. We calculate the distances of each of the data with those centers, and according to the distance, we group them into OK clusters. And the centroids first we have done. We will initiate, and after that, repeatedly we will update the centroids based on the. We will calculate the each cluster by taking the mean of the all data points assigned to that cluster. We repeat these things repeatedly, and we will find the until there is no change in the updation of the centroids. So here, after clustering, what we did is we have considered 2 parameters. One is the loss objective, another one is the voltage objective. So the loss parameter, what we consider is the including RP loss DGSC, RP loss base case. RP loss DGSC is the loss of the distribution system with DGSC, and RP loss base is the loss of the distribution system in the base case. So we have designed a fuzzy membership function such that if the loss is below 50% of the base case, it will have highest membership. And if the loss is above the 50%, then it gradually declines and ultimately it becomes 0. Such that we have designed for the first parameters, we consider a loss. And the second parameter we consider is the voltage constraint. In this voltage constraint, what we did is generally the distribution system in the per unit basis 0.95 to 1.95 is the permissible limit of the distribution system voltage. And we have considered a unit membership if the voltage lies in between 0.95 and 1.05, and otherwise a less membership we assigned to other values. And out of all the nodes calculating, the minimum value we considered that the loss objective and the voltage objective both are converted into fuzzy objectives, and that fuzzy objective is maximized using genetic algorithm. So this is the basic flow chart of the genetic algorithm. Because of the length width restriction, I could not show the entire flow. But what we did here is first we divide the data into clusters. For each cluster, considering the maximum load factor, and for that load factor, we have calculated the DGs and SEs required. So that I can show here. So first, what we did is in the data we divided the total 365 data we have taken from the either Southern Load Dispatch Center AP Transco from the website. Here I am showing here. This is the blue color line. From this data, we have collected a 365 days data. The 365 days data we have divided into three portions: one is summer and rainy and winter. So summer we consider from March to June, and a rainy season we consider from July to October, and winter from November to February. And for these three seasons, we have estimated the clusters separately. For summer season, we have divided the data into three clusters. We identified three clusters for the summer data. So these are the centroids, and these are the clustering results we obtained for the summer season. The summer data is divided into three clusters, and each cluster here we can observe the centroid and the minimum load factor and maximum load factors we can see here from this. This is the load factor. And these are the results for the rainy season clusters, and these are the results for the winter season clusters. Each season is divided into three clusters. And for each cluster, I consider the maximum load factor. And for that maximum load factor, we have calculated here the distribution generation values, DG1, DG2, DG3, and these are the shunt capacitor values. The requirements here for each cluster, we have considered separately. So for this summer season and the rainy season and the winter season also, we have calculated separately all the values. So the performance obviously will be better with the DGs and SEs that we have shown here. The real power loss reduces with compared to base case in the case of with DGs and SEs, and the voltage profile will be obviously improved with the DGs and SEs compared to the base case. This performance we have shown here. And so what we can conclude from this is the estimation will be more easy for each if we can divide the data into different clusters. Mainly an estimation of renewable energy sources to meet the required performance requirements. So how much data, how much renewable energy is available, how much power we need to get from the substation. For those data, we can definitely calculate a day by day or cluster wise that gives more accurate estimation for renewable energy sources and power generation requirements it gives. So that is the main contribution we want to show here. And considering the uncertainties, the future scope, what we can say is forecasted values of the renewable energy sources day by day, more estimation of solar and wind, more availability, forecasting those values also, those uncertainties also incorporating more better estimations can be performed here in this case. So these are the main references I'm showing here in this. Okay, sir.
So thank you, Dr. Srinivasa Rao, for your nice presentation. So from the audience, do you have any question or query? Okay, so I have few questions or query. So based on this clustering, how it can help in the future to generate the power? So
Sir,
could you shed some light on that?
okay, sir. So here, these are the clusters we have. So these are days, sir. The days, the estimation of the load requirements, we have segregated into different clusters. So
in,
for
in, in, in,
different,
in a day, so this is in a day, I think. Okay.
yes, sir.
So
Days.
that remain basically all over the summer almost same within this bound only. So as you are showing in this pink color.
It is different, sir, and because 0 to 9 it is around 0 to 8. Some of the days it is around 0 to 8. Some of the days it is
Yes,
1
it's
year.
varying fluctuation.
Yes, sir.
Some kind
Yes,
of
sir.
standard deviation is there in the
Yes, sir.
data.
Yes, sir.
Okay. So my question is how it can help in the future to generate some kind of basically this amount of power, or with this kind of power factor you need to generate the power. Okay. So how it can help?
Sir, the renewable energy sources for meeting the performance, actually the renewable integration of renewable energy sources will help, sir.
Okay.
So the estimation of renewable energy sources based on that.
So you are only considering load factor. Why you are not considering that what is the total amount of power, basically you can say power dissipation, or basically that load?
Sir, the load factor is based on the peak load, sir. The load factor is based on the total peak load. In the daily 24 hours, the load varies from every hour, sir.
Okay.
The load varies every hour, sir, here. So based on the hourly basis, this is the actual power requirement from the substation, sir. Okay, this is the centroid, the mean power required from the substation. So this gives an estimation of the power. Actually, this is the average power that we can get it required from the substation. Considering these the maximum values of all these things, we can estimate the sometimes if the power to what extent of renewable energy power required, we can calculate for meeting the performance requirements, sir. Here the renewable energy will be different. Here the renewable energy will be different. Here the renewable energy different for meeting the required voltage and power loss requirements, especially the voltage requirements. To meet the voltage requirements is more important, because sometimes the renewable energy will be less, sometimes the renewable energy will be more.
Yes.
And yes, sir. So those requirements we can estimate by cluster wise. When in general, what so far in the literature say, what they will do is they will consider the average summer value or average winter value or average rainy value. Based on those, they will estimate the values. But in this case, we can further divide them into clusters, and we can further go for fine tuning of those requirements, sir.
Okay. So you have done it for only 1 year of analysis with the data.
Yes, sir.
So
Yes, sir.
if you do the same analysis over 3 years or 4 years, so you could have get a more better picture.
Sir, actually, first we need to forecast the data, sir. Considering for that forecasted data, we need to divide them into clusters, and we can pre-estimate the requirements. According to, we can plan the renewable energy sources, sir. Yes, sir. Because actually, what we meant was, first we have, if you have forecasted data, we divide them into clusters and we pre-estimate the requirements, so that for the coming year, the economic planning will be done at the beginning itself, sir.
Okay.
So year by year, it can be more because the predictions for predicting the data, we can take long back, sir, 4 years, 5 years. But for estimating 1 year estimation will be more comfortable, sir, for getting more accuracy.
Okay. No. So you can basically compare from the previous year data, how this data is varying compared to this one.
This
so
is
that
actually
you can have
Yes,
you can have more better understanding that what will be the future demand, because the future demand will not be basically exactly depending upon the past demand. It will gradually change.
Yes, sir.
Some kind of tendency you can do analysis. Okay. Thank you for your nice presentation. So we'll move to the next participant. Real-time PCB flaw detection, a vision from more efficient and accurate future. Who is the presenter? Mr. Muhammad Sabbi Hussain, are you present? Paper number 552. Anyone is there to represent that? Okay, then we can go to the next paper. 556.
Yes, sir.
Okay, please start.
Yes, sir. Sir, is my screen is visible or not?
No, I think Dr. Srinivasa, please answer your screen.
Now, sir?
Sir?
Okay, hold on. Yeah, now it is visible. Yes, thank you.
Yes, sir. Yes, sir. Good afternoon. I'm Arpita Mary, a research scholar from Vellore Institute of Technology. Today, I'm going to do my presentation on performance analysis of single phase shift control, extended phase shift control, dual phase shift control for the resonance-based dual active bridge converter. So, first move on to the contents. What are the contents we are going to see for? So introduction and the modeling of the circuit, the principle behind the circuit, what are the types I have used for this control technique, then the performance analysis, the later on the last I'm going to end up with this, my simulation results. The first thing is I have done this for the application of EV. So in nowadays the EV is a rapid growth for the sustainable transportation. So that's what I have made this presentation for the EV application. Generally, we have a two kind of charger. The one is the onboard charger and the offboard charger. The first thing, the onboard charger, which is the charger which is present inside the vehicle. So I have made my EV charger for this kind of charging. So it has the front stage as well as the back stage. I particularly concentrated on the DC-DC topology stage. So for the DC-DC topology, so we have so many topologies we have. So in that, I have taken the isolated topology for the DC-DC stage. In that also, I have particularly taken the resonance-based topology. These are the main literature survey I have surveyed. I have made this. The first paper is all about the first paper is used for the dual active bridge converter, which is one of the isolated topology of DC-DC converter. This converter, they have in that converter they have extended the zero voltage switching, and
Your
but they
presentation are not moving.
hello.
Are you in the first page only?
No, sir. I have come to the literature survey.
Okay, so but it is not showing from my end. So I don't know about the other participant. Some kind of
Audience, can you please reply for this?
Sir, it is not moving.
Only this
it is
is
not
only on
moving.
first
Yes,
page.
from
It
other
is on the first page.
participant also they are not able to see that. Okay,
One second.
could you reshare that your slide again?
Yeah, sure. So now, sir.
Yes, make it full screen.
Yeah.
F5.
Yeah. So these are all the papers I have taken for
No,
my
it's not full screen. Make it full screen.
No.
No. Press F5.
Yes, sir. I have pressed.
So from your end, it's full screen.
Yeah. For my side, it is showing as a full screen window.
Okay, can you change the slide?
Is it moving in your end?
No, No. Okay, you check your connection and thing. So we'll move to the next one and then you can present later. Okay.
Okay, sir.
Verma presented. Vishwa Hoy 580.
Sir,
Yeah,
I'm
please,
sharing my
yes,
screen.
yes.
Sir, visible?
Yeah, your background is visible. Yeah, please open your slide.
Now it is visible, sir. I'm on the first page, sir. It is visible.
I think there's some kind of delay there. Just let me. From other participant, whether it is visible.
No, sir, it is not visible.
No,
Okay.
sir.
Okay, some kind of issue is there with your network. Okay, please
Okay.
reconnect. Okay. So
Yes,
by
sir.
the meantime, we can move to the next participant.
So can I?
Yes. Who is the next one? $592. Avinash Kumar Singh.
Yes, sir. Yes, sir. Good morning.
Okay, so please share your screen.
Okay, sir. Thank you. Sir, I think my screen visible, sir.
Yes, it's visible. Open your slide.
Okay, sir. Thank you.
Okay, make it full
It is
screen.
okay,
Yes.
sir.
Yes.
Yes, sir. So myself, Avinash Kumar Singh, and my paper ID 592, and my paper title RBFN Enhanced Leo Converter for PV grid tied EV charging with the ANN based harmonic reduction. So others are PK Dal and myself, Avinash Kumar Singh. So I am presenting. So these are our outline, like abstract, introduction, objectives, literature survey, purpose, methodology, hardware. We have proto and description, novelty, result discussion, and conclusion, and future scope, and after the references. So these are our abstract, we know, our now global power demand and EVs are increasing. So grid synchronized EV as a solution to rising global power demand. Challenge and integrating the EV with the grid, including supply demand imbalance and voltage fluctuation. Again, we have solar power integration, B2G technology, vehicle to grid, and converter technology and testing. So these are our abstract. About the introduction in the last decade, like our transportation sector is booming with the development of electrical EV as an option to reduce the global climate change, that is CO2 emission from the conventional internal IC engine vehicles. So here, like battery charging facility play a vital role in the growth of EV in automobile industry. Recently, renewable energy-based battery charging stations are developing worldwide. Among various renewable energy sources like PVRI installation is easy, and also the continuous price reduction in PV module makes it more attractive. So objective, like to extract maximum power from PV system using, we have used a relief Leo converter with the RBF and MPT algorithm, and to achieve high gain output DC voltage with purpose MPPT and relief Leo converter. To achieve energy management for the purpose system using bi-directional battery converter, we have used. To demonstrate the characteristics of the PV and battery system are analyzed using MATLAB Simulink and the prototype hardware. So these are our literature survey. So regarding the methodology, we are This is our diagram, EV. So here it is a PV, then here is EV battery charges. Again, you have bidirectional battery converter. In between, there is a Leo converter to boost the PV input, and again bidirectional three-phase voltage source inverter, LC filter, and three-phase. This is a grid. So here for that we have used RBF and MPPT with the PWM generator, and again for the bidirectional VSI converter we have used a NN controller. So these are our methodology in this. So these are our hardware proto and description. So these are a small hardware setup. So this hardware actually project aim to address the challenge of integrating renewable energy source, especially photovoltaic system with the EV charging infrastructure using advanced control technique like RBF and based MPPT and algorithm reduction. It improved the actually charging system efficiency, reliability, and grid friendliness. So key objective are to maximize the PV power output. Second, optimize the EV charging efficiency and ensure that grid stability. So application also include like sustainable transportation, energy management, and smart grid technology. It offers such a reduced carbon emission, increase energy sustainability, and enhance power quality contribution to a greener and more efficient energy ecosystem. So these are our hardware implementation system, and these are the we have used the controller, drive circuit, TLP 250, and other components. So like novelty. Integration of the RBFN with the Leo converter. Second, like low total harmonic distortion. So compared to THD value is 1.19 with the AN controller compared to the 1.84 with the PI controller. Also improved output voltage and a stable battery performance. It was very constant 124 volt with the steady current of 3 ampere, and SOC also has 60%. And also effective grid voltage and current. These are the novelty. Like these are the result, and like PV system input, then output will be 70 volt and 30 ampere. Again, you lift convert like 70 volt is input, 30 ampere. That DC is output will become a 612 volt 3 ampere DC. Again, three phase inverter like 612 volt 3 ampere DC. That is for the grid for 15 volt 12 ampere AC. These are the output, and these are the output our waveforms in like a converter waveform, and like battery waveform, grid waveform results, and like result and discussion like input and output already I explained. Comparing the efficiency in Rio lift converter is a 93.5%. It is higher than like boost, buck boost, and coke inverter. Again, THD value comparison we see means like PI control is 1.84 THD value, but ANN controller method we have achieved 1.19%. So like future scope, we can see like advanced control algorithm, again integration with the power electric system to achieve synchronous rectify with the DC to DC converter inverter to boost system efficiency and power density. Again, control technique, focus on advanced control technique for the active synchronous rectifiers to improve efficiency, stability, and dynamic response. Again, fault diagnosis and protection. So develop fault diagnosis and protection technique to increase system reliability and safety. Again, reducing the downtime. So like conclusion, this study actually represents the grid tied electric car charging method using PV energy. It enables the vehicle to vehicle grid communication through Rio lift converter. Again, supplying voltage from the solar system to the inverter. The RBFN MPPT algorithm maximizes solar power output, providing high gain DC voltage. Energy management is achieved with a bidirectional battery converter. So using like a buck mode recharging and boost mode of the depletion, and AN controller is three-phase VSI transformer surplus DC voltage to the grid. So DC voltage to the grid, recycling extra electricity during the low EV demand. The project effectiveness was validated using a MATLAB Simulink software and a small proto hardware. So these are our reference. Thank you.
Okay, so thank you for Avinash for your nice presentation. So I have few questions. First of all, you have not shown the topology of your converter. So that is quite important. You are claiming that your converter is having more efficiency as compared to conventional buck boost converter or other converter. So why it is providing more efficiency as compared to the other converter? How it is different?
No, this is sir RBFN. So it is like latest and it is their switching and other
What is the
frequency
difference you are using for that? So do you have any particular difference from there? You are basically designing the converter, DC-DC converter.
Pardon, sir?
What is the reference that you are designing this converter now? So you are saying that this converter provide better efficiency as compared to conventional converter.
Like you are telling about the bidirectional converter, sir?
Yes.
Yes, sir. This is because of that there is switching. There is due to the switching and there is a boost mode. So boost mode when we have a so that's why it is giving a good result, sir.
Okay, so do you have any schematic diagram of that your converter?
We have, but here I have not included, sir, because due to time and other, we have not included. We have included in our paper.
Okay, so do you have any reference from which you have taken that type of converter?
So we have seen some reference in before method. They have used buck booster, and better we have seen based on the reference. So we feel that it is good for us.
No, I'm talking about relieved leaf converter. Okay, so this do you have any reference?
Actually, I'm not getting, sir. Mean to say?
So RBFNN enhanced relieved leaf converter.
Okay, sir.
So that for that, do you have any reference?
No, you are asking, sir, for reference from like any paper or?
Yes. From which paper you have taken that? Yes.
Okay. That I have to check, sir. Sorry.
Okay. One of the thing is that when you because your main concentration on this paper is basically based on this. So based on this, you are basically improving the efficiency. So you should cite that in proper way and things. So that is very important thing.
Okay, understand, sir. Because I have a reference, but I am still have to check because before in method they have used a boost
That is very
converter.
important in the presentation.
Yes,
So
yes,
because
yes,
that is the
yes,
one of the main claim you are doing. You are doing the claim. So in that case, you should provide some kind of reference. Okay, other people also use that, and they also achieve that similar kind of efficiency. Or if you have modified that a little bit, so how that is better in compared to that. Okay.
Okay, sir. Actually, we have modified earlier. Actually, existing method was the booster, so we have replaced with the relief Clio converter.
Yes. That part you should strengthen in the schematic diagram, how you basically making hardware. Okay. So those parts were also quite important in your presentation.
Okay, sir. Okay, I noted, sir, your point. I'll
Yeah.
take as an improvement, sir.
The clarity in the presentation and this thing is very important in research. Okay.
Yes, sir. Yes, sir.
So I hope in future you'll do the same thing.
Yes,
Okay.
sir. Definitely, sir. Thank you for
Okay.
your input.
Okay. Thank you for your nice presentation.
Thank you, sir.
So next is 556.
Yes, sir. I'm ready for.
Okay, now you are ready. Okay,
Yes.
so please share.
Is my screen is visible?
Yeah, your screen is visible. I can see some
Yes, sir.
PDF file.
Yeah.
Please
So
open your
good
slide.
is that moving?
No, your slide is not visible.
Visible.
So I think there is a lag between your this thing. So you check your connection is good or not. Okay. Okay, so then we can move to the next one. 580. Vishwa voice, single phase, bidirectional wireless power transfer architecture.
Sir.
Yes.
So now it is visible.
Your screen is visible, but your slide you have not opened, I hope.
I have shared, but I think there is some network.
Your screen is visible. Okay, your screen is visible.
Sir.
That in the background I can see the MS Team. Okay, but I am not able to see any kind of slides.
Sir, again I am sharing.
Yeah, now it's visible. Okay, make it full screen. F5.
Yes, sir.
Yeah. Okay, start.
So good afternoon, all of you. So my topic is single phase bidirectional wireless power transfer architecture for B2G or G2V application. Nowadays, electric vehicle is increasing more and more, and the renewable energy is now one of the most essential things nowadays. And due to this emission increasing or the pollution is increasing nowadays. So mainly the renewable energy is come into picture, and after that the electric vehicle is most essentially that is taken into consideration. So my contents include then introduction, the problem background and objective, the B2G and G2V technology, then proposed methodology, simulation and result, and future scope and conclusion. After that, references. So introduction that electric vehicle has emerged as ultimately mobility solution for the future, and also nowadays also, and the electric vehicle mobility that can be also government policy is also taken into consideration, and they are also advertising this thing also. And the factors which is attributed for the introduction of electric mobility, that is dominated by the thermal mobility, and the thermal mobility is the primary contributor to the greenhouse emission. The conventional fuels are non-renewable resources, and efficiency of an electric motor is higher compared to an internal combustion engine. And the types of EV what we are using nowadays: the battery electric vehicle, plug-in hybrid electric vehicle, hybrid electric vehicle, and the fuel cell electric vehicle. The battery electric vehicle as the storage as used, and lithium-ion battery mostly used, and then after that the plug-in electric hybrid electric vehicle, that is the internal combustion engine, and also the battery is used, and sorry, the internal combustion engine is used for this electric vehicle. And hybrid electric vehicle, both battery and the internal combustion engine is used, and the fuel cell electric vehicle. So the literature surveys that in the reference what also I have followed the reference one, and also I have taken the data from the reference one, which have presented both the buck boost bidirectional converter for the non-isolated onboard battery charger used in the electric vehicle. And the second author that describes the analyze the vehicle battery storage its greatest details, and comparing 3 electric vehicle configuration over a range of driving requirement and electric utility demand condition. The third one that they have discussed about that the vehicle to grid services, including the active power services, and which discharge the EV batteries and the power quality services which do not engage battery or the require only small amount of the battery recharge. The fourth one, the references, they have provided the comprehensive survey of hybrid electric vehicle on their source combination model and energy management system to develop by various researchers. So my objective is to investigate, design, and simulate and demonstrate the bidirectional EV battery charging infrastructure for B2G and G2V power flow purpose. The problem diagram includes that large-scale integration of EV can be navigated negatively affect the load stability and reliability of the grid. So that can be that is the most problem for this. And the solution for this challenge is to that the vehicle to grid technology, when it is the regenerative braking mode, at that point we can give the power from the vehicle to grid. So first I am showing this simulating model, then I will go to this methodology. So from this simulating model, which is used to the bidirectional AC-DC converter and the bidirectional DC-DC converter. So the bidirectional AC-DC converter, which uses the IGBT, and the bidirectional DC-DC converter, that one is also using the IGBT with the buck boost model. So the bidirectional converter, so designing a bidirectional converter battery is necessary for all feasible design of an electric vehicle, and that can operate in the traction mode and energy storage system for the grid. So there are several bidirectional charger topology available. The system uses the single phase AC-DC converter. This system uses single phase AC-DC cascaded with DC-DC converter to achieve the bidirectional power flow. And the main component of this bidirectional charging infrastructure are comprised with the grid and the two directional converter that can be used for both charging and discharging purpose, and the EV storage battery. So this is the simulating model where you can see that from the supply from the bidirectional AC-DC converter, then it is going to this DC link, and then it is through the DC-DC converter. And there is also, I have given here the unipolar PWM generation for AC-DC converter and PWM generation for the DC-DC converter. So these are my results, and from the G2V mode and the V2G mode, where I have taken that the voltage which is about 310 volt, and the current is about 20 ampere. And from the vehicle to grid mode, that voltage is about 300, nearly it is about 380 it is coming volt, and the current is also, you can see here that there is a fluctuation current is about it is about 21 ampere it is coming. And these are the battery voltage, the battery current, and the state of charge of the battery for the G2V mode. When it is grid to vehicle mode, it is the SOC is increasing, and when it is VTG mode, the battery SOC it is decreasing. So the main agenda of this project is to report to give an overview of the B2G or G2V technology with special emphasis on the plug-in AC power transfer, which has proven to be the best method of EV charging. We have attempted to incorporate smooth bidirectional power flow with the use of controllers to optimize the battery charging procedure without exceeding the upper limit of the charging of the for battery safety. And the future scope that can be done, so EV integration with the demand response management with distribution network, and implementing the CCCB charging scheme, and implementing the concept of wireless charging. So these are my references. From the first references, I have taken the data for this model, simulating model, and I have also compared the result which I have not given here, that this is giving the smooth voltage and current from that reference one. So this is up to this. Thank you.
Okay, so Vishwa,
Sir.
It's a
Sir.
very good and nice presentation overall. So from the audience, if you have any question, you can directly interact. Or otherwise, I'll ask some question.
Sir, I have a question.
Sir, I have one question.
Okay, good. Ask.
In your conclusion, you have mentioned that you are implementing in the concept of wireless technology, right? So this is a normal charger. You have a AC and DC, AC to DC conversion, and then again to DC to DC conversion. Where is the wireless charging topology you are using?
Sir, madam.
Is here. So actually, in your third point, you have mentioned you are implementing the concept of wireless
No,
charging.
no. So
Where you have
that is the future research that can be done the future scope. Implementing the concept of wireless charging, that is the future research, not the now I have
okay.
done this work.
Okay, and also how you are, and in your previous slide, you have mentioned, can you go back to the simulation part, the result part?
Yes, yes.
Here, the SOC, excuse me, is it visible? So in which power rating you have designed the simulation?
Madam, it is not audible what you are saying.
What power rating of this charger you have designed?
What power rating for 1 kilowatt power,
Uh,
madam?
for 1 kilowatt. For 1 kilowatt, your output voltage is 400, right? 400 or
Uh,
something.
380, not for 400,
Uh,
380.
three, okay. So 380, your current is 20, I guess, right?
Yes, sir. Yes, madam.
Is it satisfy the 1 kilowatt? You simply just multiply the V and I, and what will be the answer for this? V and I gives the values of power, right?
No, madam.
Also you are having a high amount of current, right? Like 20 amps.
Yes. High amount of current, 20.
Which level this will satisfy? Level 1 or level 2 or level 3 type of charging this will satisfy your implementation?
Actually, it is level 2. Level 2. It is
Level
level
2.
2 is
So level 2 is
the charging.
I think it is up to 15 amps, I guess. So I'm not sure about it.
It is about
So
15
that is
amperes.
the,
Yes.
yeah, but you have made it for
Level
a
2
20
AC, it is
amps.
about 20. Actually, a level 2 AC, it is about 22 ampere up to we can take.
If you're
It is,
calculating this, the whole simulation is not about the 1 kilowatt. So that is one small suggestion on the simulation. Thank you.
yes, madam. I will take.
So I have one question.
Yes, sir.
Actually, the voltage of the battery will vary, right, based on the SOC, right?
Yes, sir.
So at the DC link,
Sir.
how you are maintaining the constant voltage when the your source voltage is varying? What is the control you use?
Sir, when it is coming to the battery, then we have given one reference voltage below that cannot be discharged. And the it is I have taken about let 50% of SOC. So below that, if the state of charge, if the charge is degrading or it is about half of this, then the voltage will not supplied to the grid.
What is your maximum SOC and minimum SOC you have taken? What is the range? Till what
The minimum
maximum?
is
Yeah. Carry on.
the minimum SOC I have taken in percentage, in percentile I have taken, and that is about 40%, and the maximum it is about 80%.
Okay, so there is a difference, right? Voltage difference will be there at 80% SOC and 40% SOC, right? It is not a
Yes, sir.
constant. So, like
Yes,
when you are doing from vehicle to grid, So how you are maintaining the constant voltage at DC link with your bidirectional converter with a variable voltage source voltage?
Sir, I'm not getting your point. What you were telling?
No, I am saying that your battery voltage is changing regarding based on your SOC. So when your SOC in charging when you are discharging the battery, the SOC will degrade, right, from the maximum to minimum. It will discharge
Yes,
it.
yes,
So at
yes,
that time, your voltage will also vary based on SOC.
yes, yes, yes.
So how you are maintaining, what kind of controller you use to maintain the DC link voltage? That DC link voltage, it is a constant voltage, right? To give to the grid.
Yes.
So how you are maintaining that constant voltage when your battery voltage is varying? What kind of controller you use? Look, I am asking for a knowledge.
Sir, sir, I have given one reference to that battery. Below that SOC, if it is below, then it will not
No, sir is
going.
asking what kind of controller you using to set the voltage, output voltage, or what kind of controller you are using. When there is some kind of voltage fluctuation, you need to use this controller to fix it. So you are controlling by PWM signal, na? So how you are
Yes, yes.
setting the frequency of the PWM signal?
Through PI controller, sir. Through the PI controller, I have seen here in this model. I use PI controller to set that uh, PWM generated voltage.
Okay, thank you. Thank you.
Okay, I have three questions. So what is the practical application? You are saying that bidirectional, sometimes you want that, okay, your energy should transfer from your vehicle to the grid and sometimes grid to the your vehicle. So why does it require? Because as per my understanding, your vehicle need to be charged. How your vehicle will generate the energy?
Sir, when in the standalone mode or when it is in regenerative braking mode, at that point we can use the power so that they can be transferred to the grid.
No, how we are generating the power from the vehicle. So that just I'm interested in that.
Sir, in regenerative braking mode, at that point when it is coming to the potential energy of this vehicle, which can be converted into kinetic energy, and after that through the vehicle that can be transferred to the grid.
I don't think that will be efficient or anyway. So people propose this kind of concept, but that cannot be efficient because anyway you cannot basically generate the energy in that way. Okay, as per my understanding, maybe I'm wrong. And
Sir.
another question is when you'll try to model the wireless charging part. Okay, so how you'll model that? What is your plan to model that? So do you have any kind of plan? So in this way, I'll model that wireless charging part. Do you have any idea, any clue?
Sir, nowadays many people are using the Arduino based also. So wireless.
No. Arduino, that is control part. Okay, Arduino is different. I'm saying about that wireless power transfer. Okay, how you'll make that? So there are many approaches are there. So what kind of approach you want to use?
Sir,
Do
that
you have
part
any
I have
idea?
not.
Okay. So
No, sir.
okay.
Yes,
That's good. You should say that I don't know, means you don't know. Okay.
yes, sir.
Okay. Thank you for your nice presentation. We can move
Thank you,
to
sir.
the I think the last 556.
Yes, sir.
Arpita Mari.
Yes, academic.
Okay. So please share your slide, ma'am.
Sir, is my slide is visible?
Yes, yes.
Okay. So first of all, I would like to apologize myself for the inconvenience. So my ID is 556. My title is about the performance analysis of the single phase shift control and extended phase shift control and dual phase shift control for the CLC based resonant based DAP converter. So I'm Arpudameri, a research scholar from Vellore Institute of Technology. So these are all the content I like to cover today. So first thing is introduction. The second thing is circuit modeling, the principle behind the circuit, and what are the types of phase shift control I have used, and what are the parameter I have analyzed. Then I will be showed in the I have simulated a simulation in the MATLAB environment. The first thing is I have developed my system for the EV application. Since EV application is a zero emission and this is a sustainable transportation which has the low emission and high mobility like that and all. In EV also we have two types of charger. The one is the onboard charger, the second one is the off-board charger. I particularly selected the onboard charger, which is placed inside the vehicle. If I go for the off-board charger, means it should be away outside of the vehicle, like the level 3 type, what to say, the DC-DC charging system. So in onboard charger, I have to, it consists of two stages. One is the front end and the other one is the back end. The front end will do the operation of AC to DC conversion. The back end will do the operation of DC to DC conversion. I have taken the back end for the rest of the analysis. In that also, so many DC-DC topology systems are available. I particularly, so mainly the topology will be divided into a resonant, sorry, isolated as well as a non-isolated. But I have selected the isolated for the isolation between the different parts of the components I have used and for the safety purpose. These are all the main papers I have surveyed for this presentation. The first paper is about, they have done the analysis with the help of the dual active bridge converter. In that converter, they have used the EPS as well as the DPS modulation. EPS is nothing but extended phase shift modulation as well as the dual phase shift modulation. And they have used these modulation in the hybrid mode. They have achieved the very small range of ZVS range, as well as the modulation. The modulation control is quite complex since they are using the two EPS as well as the DPS. So the modulation technique is quite complex. The second thing that they are also used the hybrid duty ratio phase shift modulation for SI plus SIC. The SI part is used in the primary side of the full bridge. The SIC part is nothing but the MOSFET. The MOSFET part will be used as the secondary part. So this partial part will not be suitable for the bidirectional capability. The third paper is about, they have used the single phase shift only for the LLC based converter. The LLC is nothing but the resonant components. This component based converter only used the SPS modulation, and they have achieved the ZVS range as only 32 nanosecond, which is very, very less than the proposed one. The fourth one I have taken as the phase shifted series resonant. Here also the primary side will have the resonant component. The secondary side will not have the resonant component. So in the soft switching range is very, very less when compared to the proposed one. So my ultimate aim of this presentation is which modulation will give the high high ZVS range for the switches, and also I am comparing all three modulation based on the duty ratio in order to reduce the circulating current present in the primary as well as the secondary side. So if I reduce the circulating current in the primary and secondary part, so automatically the conduction loss get reduced. Overall efficiency can be improved. So this is the first box is about the conventional one, dual active bridge. In the dual active bridge, only the leakage reactance L only will be present. So this mainly the soft stitching will be occurred by means of the current passing through the leakage inductance. So here the zero voltage switching range is very small than the proposed one. The rightmost part is my the proposed one. Here I have made some analysis and find out the resonant tank. This will give the higher ZVS range when compared to the conventional dual active bridge. So these are my design parameter. I have designed the whole system for the 500 watts, which the input of 150 and the output of 50. Then for the voltage gain, whenever we are using the resonant components, we must concentrate about the gain, voltage gain. So I have fixed my minimum and the maximum voltage gain, which is the same parameter. The minimum will be 0.1, the maximum will be 1.1. So accordingly, I have analyzed the fundamental harmonic approximation. So among the different iteration, I have selected my K and Q value. Q value is nothing but for quality factor in order to find my resonant value, CP, LP, CS, and LS. So this is my modulation part. The first part is about the single phase shift. The single phase shift, already I have told in the primary side bridge 1 and the secondary side bridge 1. The phase shift in the bridge 1 will have D1. The phase shift in the bridge 2 is D2. The phase shift between bridge 1 and bridge 2 is D3. Okay. In single phase shift modulation, the switch 1 and switch 2 will have the pulses of 50 percentage of duty ratio. Exactly, there is no phase shift between the internal phase shift of the bridge 1. Similarly, there is no phase shift between the internal phase shift of the secondary side bridge. Only thing is there will be the phase shift between the primary as well as the secondary side. So we will be using the only 1 degree of phase shift. So that's why it is called as a single phase shift. Accordingly, so I'm calculating the circulating current present in the high frequency transformer. Here, by using the single phase shift, I'm getting the magnitude of circulating current as 22.92 amps. Similarly, the ZPS range is only a 954 nanosecond, which is very less. Similarly, by using the extended phase shift is nothing but only one internal has a phase shift. The outer phase shift will be there. Then the D1 will not have the phase shift. So by using this sequences, I'm checking the magnitude of the circulating current. It's comparatively reduced than the SPS. So here the value is 13.980 amps for the circulating current amplitude value. Similarly, the SPS range is quite improved than the SPS. It is 2.453 microsecond. When my last modulation technique is dual phase shift. Dual phase shift is nothing but the internal phase shift between the internal phase shift in the bridges should not be zero. So we'll have one phase shift in primary, we'll have one phase shift in secondary, as well as we have the phase shift in the primary and secondary. So by using this modulation technique, I'm getting my magnitude of the inductor current, which means the magnetizing inductance value is 11.73 amps only. So here the ZVS ranges in the MOSFET. So I have used in the MOSFET for the bidirectional capability. So the ZVS range is improved a lot, 4.2290 microsecond. This is the overall comparison analysis. So by using the single phase shift, I have got the peak value of inductance current is 21 amps, which is very large. This will lead to the conduction loss. This will reduce the efficiency. Then similarly for extended phase shift, the peak value is quite reduced. Similarly, the ZPS is measured. The efficiency I have calculated is 94.89%. The finally, I have simulated with the help of dual phase shift control. So the IEL values gradually decreases. So this will improve my overall efficiency of the converter. So the final thing I'm going to conclude with is by playing with the different modulation technique in terms of efficiency as well as the current stress, if we can improve the overall efficiency of the converter. Second thing is I have used this modulation technique. We have so many modulation techniques. Generally, the CLC resonant based converter will be switched by the pulsed frequency modulation. But that particular thing will be used for the high loaded condition. But my objective is used for, I made this proposed one for the light loaded condition. That's why I have taken the phase shifted modulation techniques. So comparative, I have compared three modulation. Among this, I have attained the efficiency of 95.5% in the dual phase shift modulation. So we can improve this efficiency by calculating the switching as well as the core loss also. If we considering the core loss also, we can improve the efficiency. That will be my future work of my proposed one. So these are all the papers I have referred for this presentation, sir. Thank you.
So thank you. Thank you for the nice presentation. So from the audience, if you have any question, so please ask to her.
Sir, I have some questions.
Okay, good.
So how you design your parasitic elements like primary inductance, secondary inductance, primary capacitance, and secondary capacitance?
Yeah. By using the fundamental harmonic approximation method, I have simulated with the help of K and Q value. I have modeled my resonant and components.
Okay. And also another question is that why your voltage levels are different in different modulation techniques. In SPS, it is showing more than 50. Your secondary voltage range is 50 to 55. But that
Yes.
range, in your DPS, it is below 50. Your voltage is below 50, and in SPS and EPS, it is more than 50, around 80. So why this difference in your secondary voltage?
Actually, I have calculated with the help of the OC and I have designed the equivalent circuit parameters. So by adjusting these value, I will be getting the proper ZPS range. My aim is to improve the ZPS range only. So I have done with the help by modifying the R1, R2, L1, and L2 value. So I have done that.
No. What is the why the voltage levels are different? It is not in the range of your parameters. Like you showed 50 to 55, right? But your voltage,
Yes.
secondary voltage is not at that range. One is at 80, one is at 50. Why it is?
This may due to the frequency I have taken. So see, here I have taken the switching frequency in the range of 70 to 150. So for one sake, I have done with the 70 kilohertz. The other part I have simulated with the help of 90 kilohertz. Maybe that this value may get vary.
Oh, if your frequency changes, what the parameter will change to change the voltage?
Parameter will not change, but the switching sequence will change. No? So automatically the voltage, the regulating voltage will get changed.
But 500 watts you are getting because your primary is always 150. You said power rating 500 watts, but your
Yes.
secondary voltage is changing.
Secondary, so I have reduced. No, I have reduced using the transformer. So I have taken the turns ratio 3. So my output voltage will be 50 to 55. So approximately the current I will get is 10 or 10 to 12 amps at my output current.
Okay. And also in the SPS modulation, your for secondary bridge, your switching cycle is a little bit in a slope. Why it is happening? SPS modulation. Go for SPS.
Sorry, I have given, I have given the phase shift of 30 degree.
If you give 30-degree, the slope will come like this. Like slope will come.
Yes,
Like
yes. So I have dragged it, I have zoomed out too much. So that's why it's getting, if you zoom in a proper frequency, switching frequency, now this will give a square pulse on it.
with that slope, is there an effect of switching? Because the switch is not instantaneously on or off because the slope. So is there any effect of that? You're switching?
No, automatically the gradual, the dead time may change. So automatically this will allow the switches to have the soft switching as well as the ZPS condition.
Okay, thank you.
Thank you, sir.
Okay, I have two questions. So you are talking about Q. Q of what?
Yeah.
Q of the inductor or Q of the whole circuit?
Whole circuit, sir. The voltage range with the
Okay, Q
fundamental
of the whole
frequency.
circuit. And
Yes.
do you have taken care of the Q of the inductor you have used in the circuit?
Yes, sir.
So
I have taken.
what
I
is the
have.
typical Q you have considered in your simulation?
So that is a formula I have calculated, sir, for Q.
No, what is the Q do you have used? So generally we define the Q. So this the Q is in this range,
Yes, sir.
and according to do that we
Quality
basically
factor.
do equivalent
Yes.
modeling
So,
of that.
yes, sir. So here I have specified the voltage gain of 0.8 to 1.1. So accordingly, I have taken. So for 0.1
What is K here
and
in your this thing formulation? What is K?
K
What
is
do you
the
mean by K?
inductance
What do you
ratio
mean
of
by
the
K?
inductance
K
and
of
magnetizing inductance. K of
K?
magnetizing inductance, ratio of the magnetizing inductance.
Okay. Okay. So basically mutual inductance you are talking about.
Yes. Sir.
Okay. Okay. So and what kind of simulation software do you have used to design this?
MATLAB only, sir. MATLAB only.
MATLAB only. Okay.
Yes.
So whether the MATLAB taken care of non-linearity of your
No.
switching devices? I don't know how it model.
Sir, we can do, but the precise one is if we go for P spice or LP spices, we can we can we can get a more efficient than the MATLAB.
Okay. So do you have any plan to basically verify this through hardware?
Yes, sir. I plan to do with a higher degree of higher shift modulation with the help of DL and ML techniques.
Okay.
Machine.
Okay. And another thing is that basically why do you have used this bridge kind of rectifier instead of bridge kind of circuit instead of using one or two basically switching devices?
Maybe the count of switch may increase, but the thing is when we go for
No,
the higher end model of
because you are increasing the count of the switch, na, so that increases
yes,
losses also
automatically
because
the loss. Yes,
switch will also
yes.
incorporate some kind of loss.
Yes, sir. Actually, I have modified with the help of the conventional topology only. We can reduce the switch also by means of placing the diode. But the thing in future, the bidirectional capability transportation, like as my
Because you are
friends
designed
also shared,
for bidirectional,
we
so
could
so you need this kind of MOS
yes.
switches.
Yeah. For that, we have to upgrade it to the switch. Upgrade it to the switch as well as the number of count. So previously, with the help of the switching frequency, so for 20 kilohertz, we'll be using the IGBT. So more
Okay.
than 20 means
Okay. So
automatically
do you
MOS
have
will
any
be.
plan to design the controller also? Because you need to do a control, you need a controller.
Yes,
Otherwise, how you can control that?
yes, sir. So I'll be working on it. So I'll
Okay,
be working
controller
on it.
part you're not have worked till now.
No. So for this simulation, I have tried with the PI only.
Only
For
okay. Okay.
for
So you have
future,
used PI controller.
for this, yes, sir.
Okay. Okay. It was very good and nice presentation. Okay. So I think we have covered all the paper. I think no one presenting 552.
Sir,
Yes.
actually, that 552 is from Sri Lanka.
Okay.
Yeah, because of
It-
they don't have a proper network, so they are unable to join.
Okay.
Yes, sir.
Okay, then what we can do about that?
I don't know if I told, Adam sir told that one, sir.
So can I leave?
Yes.
Thank you, sir. Thank you so much.
Sir.
Okay, so then we would that on sir he will decide what to do with that. Okay.
Yes, sir. Yes, sir.
Okay, we can close this session. Okay, thank you for participating.
Thank you, sir. Thank you.